I'm Anil Kumar sharing with you an excellent question on polynomial inequalities. We are almost at the end of the session with the exam round the corner. Question number 3 here is, a square-based pyramid has a height that is twice its base length. What is the domain and range of the function if the base must be at least 1 centimeter square, at least, right? So base must be at least 1 centimeter square and the volume cannot exceed 80 centimeters square, right? That's the question for you. So let's try to understand what the question is. Let's say we have a square based, that is the base square, right? Pyramid. So we'll take a point on top and join with these points. So we get a square based pyramid. Now what is the expression for volume? For any pyramid, if you consider a cylinder, it is 1/3 of the cylinder. So we can say volume is 1/3 of area of the base. These sides are x for you. So which is x squared times height. Now in this case we are given, so let's say this is your height, right? So here the height h, you are given that the height is twice the base length. So height is 2x. Since h is equals to 2x, we could write this volume expression as v equals to half of x squared times 2x. Oh, sorry, 1/3. Sorry. 1/3 of x squared times 2x. Is that clear? So think as if 3 pyramids can fit into this box. Is it okay? 1, 2, and 3. Think like this. Then it's easy to remember or make up a formula, right? So we have the formula straight here. So we say volume as a function of base length is equal to 2/3 x cubed. Is that portion clear? Right? Units are in centimeter cube. Now, we need to find domain when it says that the base area is at least, that means area of base is how much? Is x squared. So we are saying that x squared has to be greater than equal to 1. So that is your domain, right? So that means the minimum value is x equals to 1, correct? So that is to say, that gives you the minimum value that x is greater than equal to 1. Is it okay? Now how do you get the maximum value? So to get the maximum value for x, we are given the volume. So it says the volume cannot exceed 80 centimeter cube. That means the volume expression, which is whatever, is less than equal to 80. So that gives you the maximum portion. Do you get an idea, right? So that is to say that 2/3 x cubed is less than equals to 80. So you have to solve this inequality. Okay. Since we are working with positive values, we'll only concentrate on positive answers. Right? Therefore, we didn't consider any negative value here also. So we have x cubed, which is less than equal to 80 times 3/2. Correct? So that means, let me do it on the right side, save some space on this. So what we have here is that x is less than equal to, you could simplify this 40, and which is 120, right? So it is x is less than equals to cube root of 120. Perfect. So let's find cube root of 120 and write down our answer. So we get the maximum value for x. So we know the domain now, right? So we have cube root of 120 equals to 4.93. Okay, so that means x is less than equal to 4.93 approximately. Does make sense to you? So that gives you the domain, right? So we can write domain of the function is x belongs to real numbers, where x is greater than equal to 1, less than equal to 4.93. Now let's talk about range. So basically we have x value which is between these two limits, 1 and 4.93. So what is the volume for these limits? That's what you need to figure out, correct? So let's find the volume for 1. So volume for 1 is 2 by 3. And let's find volume for 4.93. Rather, cube root of 120, right? So for this, it is 2 over 3 times 120, correct? Right, we know that volume. Maximum volume is 80, so you'll get 80 here. Is that okay? So that is how you get the volume. So volume is range, correct? So the range is basically volume for us. So as a function of x is, we can say volume is all real numbers where it is greater than equal to, so we say volume is greater than equal to 1, or 2 over 3, I'm sorry, 2 over 3, okay, 2 over 3, and less than equal to 80, which is given to us. If you calculate back, you'll get the same value. Perfect. So that is how you're going to answer this question. So in the question, you are actually given one limit of domain, the other limit of volume, and if you combine, relate these two, you get the limits for both. I hope that makes sense. That brings us to the end of this polynomial inequalities review, and I hope with that you learn something new before getting into your final exam. Thanks a lot and all the best.